Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro Electro Tech. When real audio ruled the world.
Well, hello there once again, ladies and gentlemen, boys and girls. This is Retro Ernest of Retro Electro Tech. And here on the bench we have a Technics, or Techniques, tomato for some people, SL B205 turntable, and this came in for a general servicing, health check, look over. This has been stored away for a long time, many years, from what I understand. So the customer wants to put it back into service. So I'm going to start by doing some basic function testing. I have it plugged into a current limiter right now. I'm not suspecting any big problems there, but just in case. So before I even open it up, before I remove the platter, that sort of stuff, it'll be evident if this thing is going to power up or wants to power up as soon as I swing the tone arm over and activate the power switch that in turn activates the platter, all that. So if it starts rotating, then that's good, and that also will show that we have a belt that is intact, at least good enough to rotate the platter. And if anything looks funky, well then I'll stop and pop the platter, take a look, and all that. Now, after being stored away for so long, at least I anticipate that it's obviously going to need some cleaning, probably of degraded lubricant, but maybe not. Sometimes different lubricants hold up better than others, depending on how the unit was stored, if it was stored in a climate-controlled environment, that sort of thing, and what type of life it lived. The lubricants may not be too bad. So I'll assess that by gauging the function of the mechanisms. This is an auto return table, so we'll see what happens. And also too, when I swing the tone arm over and assess its range of travel to see if it's meeting up with any resistance or if anything feels odd. And again, if this auto returns, then it's showing that the mechanism is working good enough to do that, that nothing is binding it up, including some degraded lubricants or things like that. The usual stuff that we want to assess when evaluating turntables. So anyways, I'm going to go ahead and start by doing that. Well, as a matter of fact, let me change camera angles, that way I could squeeze in here a little bit better. So let me do that. So there we go. I have it pushed off to the side a little bit, the tripod, so I could squeeze in here, because I have a softbox light on the other side, and I have to kind of squeeze in between. So if the exposure gets a little funny as I step in and out because I'm blocking the light, then I guess we'll all just have to live with that, I suppose. So anyways, let me go ahead and start by swinging the tone arm over. Let me activate the cueing lever. Yeah, that's looking good. Current limiter looks good too. Nothing looks odd there. So yeah, the platter is rotating. Regardless, unless the belt is in immaculate condition, which I doubt it. I'm sure it has some wear on it. It's obviously good enough to rotate the platter, but for the sake of doing a little bit of future proofing, which is what the customer wants me to do anyways, because like I said, she wants to put it back in service, then I will get a replacement belt. But let me just go ahead and, while I'm sitting here with the tone arm hovering over the platter somewhat, I'm going to go ahead and walk it across and make sure that our auto return end of play engages. So as soon as it does, I will disengage the cueing lever. If it does, yeah, it sounds like it. Okay, good. Yep. So yeah, that's good. And it's slowly lowering down and shutting off. Okay, there we go. All right, so that's what we want. Auto return, auto shut off. The tone arm lowered down. When I was carrying it across, I didn't feel any kind of resistance to its range of travel. It was pivoting smoothly, and that's always something that we want to look for. So everything is good there. Yeah, we have platter rotation. So let me start with getting this platter off. Let me get this mat moved off to the side over here. Okay, and I see the belt attached to the pulley. Yeah, it looks pretty good. All right. It still has, let me see if I'm in frame. It's on there fairly snug. Okay, but I do notice that when I pull on it, it is losing a little bit of its elasticity. It's not retracting as quick as it should. I can kind of feel it. So let me take a look at it here, and yeah, you can see a little bit of wear and whatnot. And like I said, it's not as elastic as it should be. It's kind of a little tight and doesn't rebound real good. I mean, it does okay, but not as good as a nice fresh new belt. And that's what I want. That's what the customer wants. Yeah, the pulley looks clean and all that. Spindle bearing and all that definitely is going to need some servicing. This thing does not rotate real nice. Okay, yeah, it's a little snug in there. No doubt the grease, the oil, whatever, is degraded in there, and the motor will benefit from a drop or two of some very clean and light machine oil. Okay, I'll usually use like a Singer sewing machine oil, or like a Zoom spout kind of turbine oil, something like that, and just a drop or two at most. Yeah, so anyways, once I get it turned over, then and there's some speed adjustments there. They could also be accessed from the bottom, but anyways, let me go ahead and get the platter back on for starters, and let me get this belt on over here. And let me get the platter back on in preparation for some testing. If I want to test some vinyl, if the stylus is good enough to do that. If I have enough stylus, it's in good enough order. So what I'm going to do now, before I actually speed test some vinyl, is I'm going to remove the stylus. As a matter of fact, let me go ahead and just do that. Let me lock the tone arm. Let me pull the stylus out. Okay. So let me get this little magnifier in there. It's not going to really matter if I'm in frame. I'll try to stay in frame just for kicks, but you're not going to be able to see what I'm looking at anyways. So let me just check out the stylus. I will try to just stay in frame just for the sake of doing so. Yeah, it looks a little worn, but there's enough stylus intact for testing. Good enough. I will need to get a new stylus, but anyways. Now what I'm going to do next, but I'm going to shut the camera off for just a moment, because I'm going to grab the leads for the multimeter, and I'm going to pull the cartridge. I'll pull the cartridge now. Just rotate the collar here and remove our cartridge. So I'm going to hook up the leads of my multimeter to each channel of the cartridge, right and left. And I want to ohm that out, make sure the cartridge is looking good. And then if that's okay, being that I have enough stylus left on here, and if I have a good cartridge, then I'll go ahead and speed test that vinyl and see what there is to see. typically the controls, after being stored away for so long, typically the controls are going to have to be serviced, of course, speed switch, the pitch adjustment, and so forth. And also too, before I test the cartridge, I will mention that probably when I'm in there, depending on how the lubricant looks, the state of the lubricant, condition of the lubricant, I may end up cleaning some of that out, at least what's accessible, without doing a deep dive and disassembling everything, because that's just not in this level of servicing unless the customer would want me to do more if I had to do more. But if it looks okay, then I'll just leave it as is. Anyways, once I do the basic function testing that I just talked about, I'm going to move this over to another bench, or I might end up moving another turntable over here. But some of you may recall that I was evaluating a Pioneer PL205 turntable. Was it 205 or 250? PL250 turntable. And that came in with a stack of Pioneer equipment that I just recently did a little mini marathon evaluation on. So in the interest of just working efficiently in the shop and getting these things out the door, I'm going to service both turntables at the same time because they need essentially the same type of service. So I'm going to put them side by side and do that in this video. So when I eventually end up with two turntables on the bench, I'll be going back and forth and just showing service of both, because like I said, they're going to undergo pretty much the same level of servicing and all that. So anyways, let me go ahead and get the lead stretched on over here, and I'll be right back. Okay, so I have the probe hooked up to the pins of the right channel, the red and the green. Nothing groundbreaking there. So I just want to read the right side coil and make sure that everything is ohming out okay. Then I'll swap the leads over to the left channel, the blue and the white. So and we'll see what we have and make sure that the coils of each channel on this cartridge are ohming out and that they're fairly equal-ish. There's going to be a little bit of variation. That's normal. But just make sure that they ohm out fairly equal with one another. So let me go ahead and pan up to the meter. So there's our right channel, and we're at like 1.5 k ohm on that one. And let me swap over to the left side. There'll be a little bit of kind of jumping around and all that till I get these leads secured. Okay, and there's our left channel there. And we're at what, 1.478, so almost 1.5K, just like the other side. Close enough. There's going to be a little bit of variation in these, and that's fine, that's acceptable, that's in the ballpark. So our cartridge is looking good. Okay, so I'm ready to do just a quick speed test, an audible speed test. I will probably, eventually reposition the camera so that we can view the strobe and the speed dots and all that. But for now, just a quick audible test. I have a piece of vinyl on here that I'm familiar with, and probably most of you are familiar with, Pat Benatar. We kind of know how her vocals sound, and these are familiar songs, and we know more or less at what speed they should be playing at. All right, so I have and I'm only going to camp out on that for just a few, just so we can get an idea of the speed. I'm not going to keep playing it because of the YouTube copyright situation and all that. But I'll let it sit there for a little bit, and just so we can gauge what the speed is. So I have the speed switch set to 33 RPM, of course. I have the pitch adjustment sitting somewhat centered, and that's where the pitch adjustment should sit. So if everything is adjusted properly, the speed and all that, then with the 33 switch engaged, or the switch engaged to 33 RPM, set to 33 RPM, the pitch adjustment in the center, then we should have normal speed. All right, if not, then that means that I'm going to have to do some speed adjusting with the variable resistors, the VRs, down at the bottom. Well, I'm going to have to hit it from the bottom. They're accessible from the top, but I want to access them from the bottom with the deck up on blocks, so that I can reach under there with a screwdriver and, you know, tweak around with things and all that and get the speed set right if the speed isn't set properly already. Also too, just for info, you'll see over here my little battery operated mini amp that I have sitting there, which is obviously hooked to the RCA outputs. Okay, that way I don't have to mess around and hook this up to my shop, you know, amp and all that. And so let me turn this little mini amp on good enough. And before I actually drop the tone arm down, let me just go ahead and cue it up somewhat. And again, like I said, this tone arm is moving kind of slow as far as you know, when I disengage the cueing lever, it's going to lower kind of slow, and that's okay. I'm not going to be messing around with the cueing control because it works. But anyways, yeah, right off the bat, just looking at the speed dots and the strobe and all that, this looks like it's probably slow, but whatever, we'll check it out. So, a little disclaimer: by no means do I have any rights to this music. I'm not trying to exploit anybody, Pat Benatar, any of the corporate people or whatever. This is strictly for the purpose of just testing a piece of vinyl on a turntable, for crying out loud. So I'm going to keep it very brief, and there's my disclaimer. So let me go ahead and lower this down and see what we have in terms of speed. I can tell the speed's going to be off already, but okay, it's set down. Yeah, it's a little bit slow. Let me okay, I am able to get the speed dots to lock, you know, via the strobe and all that. Okay, let me okay, so it's doing okay. I mean, I'm able to get it to lock in place with the pitch adjustment, but I had to move it quite a bit to get it where it needs to be. So I need to tweak around with the speed adjustment. Now let me go ahead and do the same thing with the with a 45. I'll be right back. Okay, and now I have a 45 in place, as you can see. Got everything queued up, and I have the pitch adjustment centered more or less. Speed switch engaged for 45 RPM. So let me see what there is to see. I don't have the speed dots locked. Let me look at something real quick. I'm gonna kick the light off real quick. Yeah. All right. So let me go ahead and drop the tone arm down and see what we get. This is Dr. Hook and the Medicine Show, cover of the Rolling Stone. And let me see. It looks slow. Let me see if I can bring it up. Now that's, I can't get it, I can't get the speed correct with the pitch adjustment. It sounds like Satan the Devil is singing the cover of the Rolling Stones. So anyways, yeah, not good. So a few things. Obviously the controls are going to need servicing, multi-flush cleaning, and work them real good, and I'm sure that's going to help out a bit with the instability with these controls. That's pretty common stuff. But I have a feeling, of course, too, I'm going to have to adjust the speed pots, the VRs, variable resistors. So at least I know where things stand there. Other than opening this unit up and gauging the condition of the lubricant and just making sure that everything physically looks okay in there, which I'm sure it does because it's mostly working. Other than the servicing that I talked about, and of course having to, maybe a couple drops of oil into the motor and the spindle bearing and all that, the usual stuff, I think this is going to be fairly straightforward. So now I'm going to figure out whether I'm going to move this turntable here to the other bench, one of the other benches, because I have several in the shop, of course, that I have to shuffle things around with, but or if I'm going to bring the other turntable that I'm going to be working on at the same time, the Pioneer PL250, over here and start. But anyways, that's for me to figure out. And when I come on back, I'll have both turntables probably propped up on blocks ready to start the servicing and go from there. All right, so I have both turntables, or parts of them, side by side here. The Technics SLB 205 over here and the Pioneer PL250 over here. So I want to get started with servicing the speed controls. Both units had their instabilities. The Pioneer over here wasn't as bad as the Technics over here, but nonetheless they both need to have their speeds dialed in. So I want to start out with removing dirty controls from the equation, because that's a very common cause of speed instability. So before I move into actually adjusting the little VRs to dial in our 33 and 45 RPM of both units, well, I want to make sure we're starting off with very clean serviced controls. And before I actually start adjusting VRs, you can see here I have the motor board from the PL250. We have some adjustment pots here, or VRs, variable resistors, VR1 and VR2. And over here on the Technics, you can see the access holes for VR2 and VR1 here. Okay, so I'm going to be making those adjustments obviously in the very end, after I have everything back together, ready to go, everything serviced, cleaned, relubricated, all that jazz. But I want to start out with clean controls, of course. So, excuse me. So I'm going to start with that. Now on this board here, the potentiometer and the speed switch are very accessible, just the way it sits right there. I am going to, with a little pin vise, and I've demonstrated this before in other applications and amps and receivers when I'm going in servicing these types of switches here. Actually, let me zoom in just a little bit so you can get a better look. But these are very common switches, and sometimes, and I've demonstrated where toward the very rear, I will, with a pin vise, very carefully drill a little access hole, just pop through. And I do that so that I can get a good flow of contact cleaner circulating through the switch while I exercise it. You know, I'll exercise it over and over again and hit it with that contact cleaner, but I want to be able to get my applicator in there. There's a little tiny, well, that's not much of a hole, plus the body of the switch internally kind of blocks that little tiny hole that you might see there. But I need a bigger hole, and I need it toward the rear where the cavity is empty there. And I'll explain it a little bit more as I go into it. I'll kind of show it. But when the switch is disengaged, when it's out, there's a hollow section in the body of this switch, and that's the area that I pop a little hole through so I can get my applicator in there, flood the switch with contact cleaner while I exercise it. That's the point. This potentiometer here, its port opening is on the bottom facing the board, but that's easy to access with my curved applicator. Get up in there, shoot that out several times while I, of course, exercise the control over and over and over again. So that's essentially what I'm going to be doing on both units, okay? Same thing over here. I am going to remove this assembly a little bit better here so I have better access, you know, pull this all out. But same thing. And I'm going to get started on that. Well, what you're looking at here is the little VR potentiometer for the pitch control. I have it opened up right now, and let me just mention real quick, I'll kind of show you how to get into it. It's very easy. So this board here just drops down. It's very evident. You can see I have the assembly here, just unscrewed, so I can lift it out if I need to, okay? It's just a couple screws, no big deal, and it's very evident once you're in here and you're looking at it, so I don't have to explain it. But what I will explain is that this little board here, VR3 board, okay, it just drops down into into a slot here, and it clips in place. And then once it's clipped in place, you see the screw hole there. There's a screw with a washer that just holds the board. Once it's clipped down in there, there's a screw and washer that situate over the board here just to hold it in place, okay? So the VR here has this little fiber washer, you know, that sits over. It kind of snaps down, and when the little fiber washer is snapped down into place, well, it is somewhat sealed. But all you have to do is just get a little razor and just, let me kind of tilt this a little bit, and you can see a little bit of side view. You just get a razor and just lift it right off. This little fiber washer will lift off, and then you have access to the internals here. And what you're looking at right here is the wiper. You see the little metal structure here? Well, this is the wiper that rotates around on the resistive track. So I'm just moving the wiper back and forth to get it out of my way while I clean the resistive track there, okay? I hope you're seeing all that. I'm kind of glancing up at the screen a little bit. I got one of those screens that kind of flip around on the camera. So anyways, I'm using, because this is a very small pot or VR, I'm just using these little tiny swabs here. Okay, you can find them all over the place online. They're just those little, like, they're used in the cosmetic industry. So I'm using some anhydrous alcohol here. I'm not even using contact cleaner, just some anhydrous alcohol, 99%, on this little swab. And then I'm going in here and cleaning make sure my fingers aren't in the way. Okay, going in here and just cleaning each side of the resistive track as I move that wiper out of the way back and forth. I'm just cleaning the resistive track. And you see what I'm doing. Nothing to it. And then I'm going to follow up. I'm not going to show that on camera. I just want to get to this. But after I clean this track real good, I'm just going to put 1 drop of fader lubricant and just kind of smear it around in there. You don't want to put a lot of lubricant. You just need a tiny bit, literally 1 drop, and just smear it back and forth on the resistive track. And that's about it. Once you get this little fiber washer here popped back on to seal over the top of the VR, then there's just a little screw. You just put this, you put the dial back on here, the little wheel back on, and it's evident how it goes on. It's keyed for the most part. So you just drop that back on, and then there's a little washer and a screw that attaches it back in place, and you're good to go. So that's about it. I just wanted to point that out because you do have to remove, you have to remove the little knob here, just like I said, a screw and a washer, and then you'll see what looks like a sealed pot or VR. It is sealed with this little washer here, and you just get a razor and just pop this little fiber washer off, and then you have access to the internals. And you can just move that wiper back and forth so you can have access to the track, clean it up, and then follow up with a drop of fader lube, and you're good to go. Okay, now you can see that I have some meter probes on the potentiometer that I just cleaned out. And why am I doing that? Well, I want to check that after cleaning and relubrication that the range of travel of that pot is nice and smooth, that there's no noise in it or intermittent behavior. And the way I'm doing that is, you'll see over here, I'll let the exposure adjust. I have it on the meter there, so there we are here, and there we are here. Okay, so if you pay attention to the meter face, we're concerned about the smoothness of that needle, and I'm going to be doing a few readings, and I'll explain what I'm doing and why I'm doing it. So I have that little knob back on the little VR there. I'm clipped on end to end on this VR, so I'm going to rotate the control, and we're just concerned with how smooth it's transitioning through its range of travel. Okay, all the way up to about 4K ohm. I'm on times 1K on the meter. Now I'm going to go back down. And you see how smooth it's transitioning? There's no jumpiness, no jittery movement of that needle. Okay, because the connections between the wiper contact and the resistive track are nice and clean, relubricated. Everything is moving really nice. Okay, and that's what we want. So that's one test I want to do after I clean pots and all that. Okay, so now I'm going to switch meters and show you what I'm going to do next. Okay, so now I have the DMM set up, and the reason why I'm doing that is because I want to find the center of the pot. Okay, so on one end here you can see we have 0 ohms, close enough. All the way at the other end, about 4,444 ohms. So let's drop that down to about 2,222-ish, close enough. And we don't have to be exact here, but let me just find the center point of this pot, ohmically speaking. All right. I'm not going to get too crazy, but let me just at least get it pretty close. Yeah, let's see. Yeah, I think, so good enough. Right there. Close to 2,220, close enough. So what I'm going to do now is I'm going to estimate from there where the center of my, I don't know if I'm in frame, I might be, but I'm going to estimate where the center of this dial is, and I'm going to score a little line in it, and I'm going to fill that with some white, a little bit of white paint, and that way I have a little white line scored into the center of this dial here, so that when I do my adjustments on the top side, I mean from the bottom side, when I go under there with a screwdriver and adjust the speeds, I'm assured that my pitch control here is pretty much centered. Now yes, you can estimate that by rotating the pot on the top side. You can rotate it and count how many times you rotate it, and then, you know, split that in half, and you'll be at about the center point. But I want to get it a little bit more precise, so that's why I'm doing this. So anyway, so that's what I'm going to do. I'm just going to score a line in the center of this dial and fill it in with a little bit of white paint, and then I'll have an index line for my adjustment top side when I get to that. Okay, so that's what I'm trying to explain. All right, so we're all done with the pitch VR. Okay, and on the other side I have a little notch marking the center position, as I mentioned. So now what I'm going to do is flush out the actual speed switch here that toggles between 33 and 45 RPM. Now this is another one of those push button switches. It might be a little harder to, let me reach over here and flip my screen around so that I can kind of see it, because I want to stay in frame here. But this is another one of those little push button switches that are pretty common. I've dealt with these switches before. I'm familiar with them. Same thing with a lot of these receivers and amps that have these push button switches and all that. So this is this switch is fairly sealed up, and yes, it's not hermetically sealed. It's not void of atmosphere or anything like that. So the contacts could get tarnished, oxidized. Little bits of garbage can work their way in through the front over time, where the plunger passes through into the body. So there is a necessity for these things to be cleaned now and then, as we know, because of the way they behave and the way they become unstable and fickle and all that when it comes to these speed controls. So the way that I gain access into these type of switches, and remember, I'm familiar with them, and I mentioned earlier that I will oftentimes drill a hole in the back. Again, when I say drill a hole, I'm not talking about using a power drill. Sometimes I'll use one of these little Archimedes drills here, and some of you are familiar with these when you pump them and they do their thing. But I move very slow, and when I get to the point where I'm going to pop through, I can feel it, because the fill changes as far as it kind of starts to bind a little bit, like I'm meeting up with resistance. And then I'll stop with the pumping when I'm using an Archimedes drill like this, and I'll just take my fingers on the chuck and just rotate it slowly. And then when I pop through very carefully, very slowly, then I'll extract the bit so that if there's any little shavings, I will pull out. And also too, the thing I didn't mention, when I'm kind of pumping through, I'll stop and I'll wipe away any plastic dust, and then I'll go through a little bit more, wipe away a little plastic dust. You get my point. I've never once had any sort of big plastic shard that has dropped into the body of a switch that has obstructed the mechanical function of the switch. I've never had that happen. In all the years that I've messed with these, this is a known technique. Other techs do it. It's been around for a while. When you need to gain access into a switch and you're familiar with the switch, then there you go. And I mentioned that when the switch is engaged, the plunger, the contacts kind of move rearward, obviously. So you don't want to even carefully drill into a switch that's engaged. You disengage it, and when the plunger, contacts and all that, the shuttle in there moves forward, it'll leave a little bit of a void in there in the cavity where you could safely pop through. But again, that's most of the time in most cases, but there can always be the exception to the rule, so you have to kind of enter this territory, at your own risk, assume your own risk, take responsibility if something goes wrong. Don't blame me if, something gets damaged. A lot of times that's the name of the game. You have to kind of come up with workarounds to things. Now that this equipment is as old as it is, certainly, Technics, Pioneer, all these companies, they didn't really anticipate, I don't think anyways, that people were going to be working on their gear and having to come up with these workarounds 40-something, 50 years later. So a lot of this stuff, they didn't really design these parts to really go on this long. So they didn't, I don't think they weren't thinking of serviceability is my point on switches like this and whatnot. But now that we are doing this stuff and we, in this case, we have these workarounds to gain access and all that, we're moving into that territory at our own risk. And if we damage something, well, that's the way it goes. And sometimes we have to take that risk. So, yeah, anyways. So enough of that. I know it's kind of a discourse, but you know what? I'm the type of person that if I show how something is done or how I do something, I'm not going to tell you just to do it. And, I should do it because Retro Ernest told me so. No, I want to really drive home the principle-based aspect as to why I'm doing it. And, if I'm going to teach something, I want to show somebody how to think their way through and understand the inner workings. And like I said, where the shaft and the shuttle is located when the switch is engaged versus disengaged, and how you can safely enter the rear of the switch carefully in most cases. So I'm sharing some principle-based stuff, not just, just do it like this because I do it. No. So anyways, that's that. So discourse over. So I'm going to flush this. I do have the access hole there so that I could drop my, let me position this so that my fingers aren't in the way, so that I could drop my applicator that's on my can of contact cleaner into the hole, and then I'm going to flush it out multiple times. I'm going to work that switch over and over again until I'm satisfied that that switch is nice and clean. And then this little hole here, I will end up using a little tape dot, or you can cut a little piece of tape or something and just put it over the hole, do a nice neat job, plug up the hole, and then that's it. The contacts, they'll have some life left in them after that, and there you go. So I'm going to move on, and I'm going to do that first to the switch, flush it out, work it, and then I'm going to do the same thing on the other turntable. I'm not going to cover as much detail because I've covered enough on this pitch adjustment and this speed switch. I covered enough. It's going to be the exact same thing on the other side. I will roll a little bit of footage because it's a different kind of potentiometer on that one. So I'll just kind of show a little footage of me flushing it out, all that stuff. But I'm not going to go into the detail with the meters and showing the needle transition through its range of travel and showing that the pot is nice and clean, that it's not jittery or whatever, all that stuff. So anyways, let's move forward. Okay, so on this board here, I want to get the pitch control desoldered from the board because I'm going to go ahead and open it up. Let me go ahead and get this desoldered here. All right, good. All right, let me get this pot out. Okay, so the pitch control, potentiometer, whatever, is desoldered from the board, as you can see. As far as getting inside, it's really easy. I've already pried back these tabs. You can see the, let me get a pointer. You can see these 4 tabs here, 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 and here. So you need something small like sometimes you could use a little pair of flush cutters. You have to be careful when you're using them that way to pry these tabs open. A little tiny, very thin screwdriver, something like that to pry these tabs back. On some of these pots, the tabs are a little thinner than others, thicker than others. These ones are fairly thick, so you have to use a little bit of force, but you got to be careful because you don't want to snap the tabs off. If you start snapping the tabs off, you're not going to be able to get the, the cover back on the pot here. So if I flip it around, you can see that we have our resistive track. You can see right here, I hope so, you can see our little set of wipers that rotate around on this black section of resistive track. So the black, the black little track that you see there is the resistive track. And let me go ahead and rotate this around. And you can see the contacts riding on the track there. So I can't, with this pot, I can't push the shaft out that way. The way that this disassembles, you see the little, you see the rear of the shaft, it's kind of flared and bent over onto the contact carrier. This plastic disc here is what the contacts are affixed to. So if I was going to separate these halves here, the phenolic board that has the resistive track or carbon track on it and this contact carrier, I'd have to grind down this little section of shaft here that's flared and press fit onto the disc. I'm not going to do that, obviously, but I have enough access where I can either spray contact cleaner, but I'm going to use some anhydrous alcohol in my little squirt bottle and just get it in there and use some of these little micro swabs to reach in there and just clean that track over and over again to the point where I get it nice and squeaky clean. I can do that because I have enough access here, no problem. So there's really no need for me to separate that contact carrier anyways. So that's just what I wanted to point out, but it's going to be the same routine like you saw in the other carbon track, where I'm just going to get my swab and clean, and I'll move this contact carrier little by little. I'll move it a little bit, I'll clean, I'll move it a little bit, and I'll clean, kind of scrub, and move it a bit, and so forth. So I'll get this a lot better than I would if I was just to spray contact cleaner in from the opening, the port on the bottom of the pot, especially now that I have it desoldered from the board, I have the cover off, so I could do better of a job. Now the reason why I'm going a little bit deeper on these controls is because most of the problems that are being exhibited by both of these turntables have to do with speed instability, so I'm really going to focus the budget, the customer budget, on servicing these controls thoroughly. And yes, I'm going to, explore or evaluate the mechanism and make sure that I don't find any grime or, debris and crap in there, and I'm going to blow it out with a little compressed air. I'll probably do a little bit of light surface cleaning of the mechanism a little bit where I could reach it and reapply a little lubricant, but that's not where most of the money's going on this, because the mechanisms seem to be behaving themselves, other than I do want to focus a little bit more attention on the spindles, the bearings and the spindles, because on the Technics, I feel a little bit of resistance in there. So I want everything to rotate very freely with the minimal amount of resistance as possible. Again, the motor shafts, the spindles, and there you go. So I'm going to put a little bit of effort into that, but most of the effort is going into servicing these controls, because that's where most of the issues seem to be, is in the instability of the speeds. And then of course the other stuff is just routine, the belts and new stylus and all that. That's just routine stuff, but otherwise that's it. So let me get this cleaned up. I'll get it soldered back in, and then I already have an access hole. Let me go ahead and actually reposition the camera here. Okay. I already have an access hole, as you can see, at the rear of this speed switch. So after I work on that pitch control, I'm going to be flooding this switch, spraying it out with contact cleaner and working the switch, you know, over and over again. Okay, same thing like I did on the other side, and that's the extent of what I'm going to show here. Okay, so here is yet again another tip I'm going to share with you. It's pretty straightforward, but in case some of you don't know, in this situation where I can't separate these two halves without a bunch of drama, the contact carrier and the phenolic with the resistive track, well, I noticed that these contacts, the metal is quite tarnished. Now, I cleaned up the top side of the contact, but that's not the part that comes into contact with the resistive track, of course. I cleaned it anyways, but now I want to, of course, clean the contacts that actually make contact with the resistive track. So being that I can't separate the halves, how am I going to get under there and clean that? Well, so I have a little strip here of about 1,000 grit-ish sandpaper. I just have little scraps laying around that I save. I think this is about 1,000 grit, but in other words, very fine sandpaper. And what I'm going to do is put my, you can either put contact cleaner on here. I'm using anhydrous alcohol. So I'm running it through wet, and I'm going to slip it under the contacts. Okay, I'm underneath the contacts. I don't know if you can see that. You might be able to. Actually, you probably could because it's that brass on black. So anyways, it's probably pretty visible. I can't see the back of the camera right now real good. So let me just make sure I'm in frame. Yes, I am. And then I just drag it through a few times here and there. Let me slip my... Okay, run it through a couple times. Run it through a couple times. You really, I mean, you probably could go back and forth a little bit. Yeah, you can. But if you do that, yeah, make sure it's wet, because the one thing you don't want to do is on the backstroke cause those contacts to kind of bend. So that's again why you want to use a fine sandpaper too. And yeah, if it's wet, then actually you can move it back and forth okay. But be careful when you do that. It's probably just better to pull it through a few times. All right, but if it seems to move okay back and forth, and it doesn't look like it's going to bind up and bend the contacts, then I don't see a problem with that, like I'm doing. Okay. So I think that's about good enough. Okay. So and then I'm going to flesh it out a little bit. And you're good to go. I'm sure those contacts on the bottom are nice and clean now. And that's about it. So let me go ahead and get this pot back together. Actually, one more thing I'll cover before I move on and get this pot reassembled is on this little micro swab here, I put 1 drop of lubricant. So I'm going to do the same exact thing. I'm just going to move along, rotate the shaft, and add my lubricant. Just brush it on lightly along the track. Again, I'm not putting too much, just a dab as I move along the track here. Hopefully I'm in frame. Yeah. So I'll just work my way around, turn it just a little bit, distribute the lubricant from the tip of this swab, work my way all the way around. And all the way around, and I'm just putting a light sheen on the control. So there, we're looking good. So the track is lubricated, and what I will do here also is let me get a clean swab and just wipe off any excess around the track. As I bump the camera, I'm just wiping off any excess around the track, because I only want a light sheen of this fader lube. That's about it. Okay, so everything's looking pretty good. That little thing moves around. I got to lock it in place. Okay, so once I get this pot back together, I will be right back. All right, so I know I said I wasn't going to show the meter again, but I'll just go ahead and do it anyways real quick. So I already centered this pot. It's a 5K pot. I centered it at 2500 and mark the control knob. So that'll make life a little easier when it comes time to center it and set the speed like I already said. But you can see the pot is nice and clean as it moves through its range of travel. Right about to 5K, back down. I'll do it a couple times. Again, we don't want any jitter, any intermittent behavior, any dropping out of the needle. So yeah, everything is looking nice. So there you go. Okay, so the controls are completed, and the one thing I want to point out before I move on is the little access hole that I established on the switch here, on the speed switch. You might be able to see, as a matter of fact, let me zoom in. Yeah, that's good. You might be able to see where I used a little adhesive strip to seal over the hole that I established. So also too, on the potentiometer, I cut out a strip of adhesive that wraps around the body of the, you can probably see it on the other side too, it just wraps around to seal the port, the access port on the bottom. So this will help with little pieces of dust and debris working their way in over time. It's not going to make the switch in the pot completely impervious, but it will slow down any dust and debris from getting in. So I like to do that. It's just a little extra touch. Same thing with the other control over here. The switch anyways, let me just kind of zoom in a little bit more before it blurs. And same thing on this, on the body of this switch. Before I put the bracket back on, you can see the strip of adhesive covering over the hole that I established. And this pitch control pot on this Technics, it was already sealed by that fiber or plastic washer. So yeah, it's important to do that. At least I like to do it. It's an extra step, but you know, it's just something that is good to slow down the infiltration, if you will, of dust and debris. So I just wanted to point that out. And now it's time to move on to some mechanism maintenance. Really, what this is all about is just going through and mostly doing an evaluation. So during the preliminary evaluation of these units, the first order of business was to make sure that the mechanisms were functioning, the auto return mechanisms, and that the tone arms were swinging freely, pivoting along their ranges of travel freely, no obstructions, or anything that would indicate there's something bogging down the mechanisms, okay? Because if that would have been the case, I would have, of course, addressed the customers to that fact, and that may have been a game changer when it comes to cost. Because for me to go in and strip out mechanisms and really go in and do a deep cleaning, relubrication, well, that gets considerably more expensive because there's a considerable amount of time involved in that. So because everything was working okay as far as the auto returns, the tone arms, and you know, moving along their ranges of travel, pivoting just fine, in other words, and the queuing levers are working, then I knew that things probably weren't going to be too bad in here, meaning the lubricants, for example, aren't so bad that they're causing things to gum up and stick and malfunction. So I am going to evaluate and maybe do a little bit of light surface cleaning, as I already mentioned. But the main thing is I want to get the spindle bearings, the housings, you know, the hubs and all that cleaned out and lubricated, and just kind of blow out with a little bit of compressed air the internals of these two turntables. Add a little drop or two of oil around the motor shafts, just to kind of, again, make sure that everything is going to rotate nice and free. So that's the level of mechanism servicing that I'm going to do. So anyways, let's go ahead and get into things. I'm going to start with this unit here because there's a few specific things I want to point out as I maintenance the platter or spindle bearing, assembly. So let me go ahead and get to that. I'm going to reposition the camera so that I can fit in here and do a little bit of work. And that's about it. So from this point forward, things are going to move a little quicker because this video is getting long and I still have a few things to go. Still have to set the, set the speeds and do a basic setup on both of these turntables. So I want to get moving on the mechanism maintenance. So anyways, let me go ahead and reposition the camera and I'll be right back. So in the interest of time, I already removed the bracket that sits in this position here. Okay, it just pretty much drops down right in here. All right, and you can see the hub that the spindle extends through. So I just move these off to the side. But this little spindle gear, I'm going to reposition the camera and hone in on it. That's going to kind of be the topic that I want to discuss regarding that. And the spindle well or housing there, all that's going to happen there is I'm going to get some swabs and some cleaner. I'll probably just use some alcohol on some swabs, and it's just going to be a lot of rinse and repeat, getting that hub area all cleaned out and then re-lubricated. But this gear here, there's some points I want to bring out about it in case one of you are ever servicing this. So let me go ahead and do that and change camera positions. Okay, I'm going to try to keep this in frame. Hopefully I can do it, but you're looking at the spindle and you're looking at the gear. All right, that connects to the spindle. Now where it connects on the spindle, and hopefully you can see enough detail because I can't zoom in any closer or things will blur. So there's a little recessed area, a little groove on the rear of the spindle, okay? This is the part of the spindle that pops through the housing, from the bottom of the deck. And obviously this is the top side of the spindle, or maybe it's not obvious, but this is the top side of the spindle. So this gear, it clips on, it clips onto, if this is inserted, this gear would clip onto the spindle, and these tabs, these 4 tabs, and hopefully you can see them, 4 little plastic tabs in there that snap in and lock into this recessed little groove there. Okay, so when you're wanting to remove the spindle so that it will drop out of the housing or the hub so you can get in there and clean everything and of old grease, then obviously you have to remove these tabs from that recessed section of the spindle here. Now, yeah, these plastic tabs, they are plastic, so there's that pucker factor there, wondering if you're going to break one of them when you're trying to bend them back a little bit, and that's a possibility. So this is one of these areas that you have to take a gamble with. I'm sure that Technics, they probably had the special tool that spread all 4 of these little plastic tabs at the same time so that the spindle would just drop out. But I don't have such a tool. I'm sure that if I put my mind to it, I could make something, fabricate something that would allow me to spread these at the same time. Maybe one of you who want to get into servicing these can get clever with something. But I've just always used a pick, and what I do is, well, when these tabs are locked into that groove, I'll get, with my other hand, I will get a like a punch that is wide enough to fit over the top of this spindle rear, and I'll just rest a punch on there and kind of press a little bit to put a little pressure on the spindle, just light pressure, while I bend these tabs back slightly, just a little bit. You can see me doing that with the pick here, bend them back slightly, and sometimes that's enough to pop the tab out of the groove there a little bit, just a little bit. And then I'll go through and kind of quickly but carefully try bending back all the other tabs while I'm pressing, just to pop them out of that groove enough. And usually after a few tries, sometimes it doesn't work the first time, but after a few tries, then the spindle will just kind of drop out because I'm putting a little bit of pressure on it with, a punch. So with a little pressure exerted on it and bending the tabs just enough so they hopefully pop out of the recessed little area, that groove, I've gotten these spindles obviously to drop out, as you can see. But sometimes, again, you have to try more than once. You can also try multiple little picks, tools, little tiny screwdrivers, whatever. If you can kind of get them in there and pull them all back, and especially if you have some extra hands and you can kind of maneuver it. I do it myself, but sometimes it takes a few tries. So that's what I wanted to point out, but the emphasis is that you really got to be careful with these plastic tabs, because if you broke a few of these tabs, that would really stink, because these are the tabs that lock into the spindle to hold it in place and all that. So yeah, so there you go. I just wanted to point that out because that's pretty specific to this, this turntable here. So anyways, let me go ahead and get back to it. All I'm going to really do is clean out that hub that the spindle drops into, the spindle hub. I'm going to clean that out with some swabs and cleaner. I'm going to use alcohol and just go in there and really clean it out. I'm going to clean this gear, of course, too, get it all cleaned out, and then get into some relubrication there. And the same thing with the other turntable. I'll come back when I'm going to access the hub there and clean out that bearing and that housing, that well, and go from there. So anyways, let me go ahead and get on with it. All right, so everything went well with getting the spindle reinserted into the gear, okay, that I pointed out a moment ago, and the bracket reinstalled. I just want to move through this real quick now. I'm kind of needing to move forward fast from here on because this video is getting long, like I said earlier, and I just want to get done and get through it because I've got a lot to do. I'm really inundated with work. So I just mainly wanted to show you guys a little bit more detail when it came to servicing the controls because of the speed instability of both of these turntables, the Technics and this Pioneer. So I already went through and evaluated the mechanisms of both units, and I didn't really feel the need to go into that too deep because I wasn't going to really do anything anyways other than a very light cleaning, which I did. I cleaned some stuff just real quick and dabbed on a little bit of lubricant, mainly on the other turntable. This one wasn't too bad, actually, to be honest with you. So I just left well enough alone and got my, just got my little air blower here and was, going through and blowing out the mechanism, getting any dust out of there and all that. But again, being that everything was working mechanically, the return and, the tone arm, the pivot, and setting down and cueing and all that, everything is working. I wasn't going to do any more future proofing with the mechanism because the budget's not there for that. And I'm not going to say any more than that because I'm burning up time. So what I am going to hone in on here is the motor board on this SLB 205 because I want to point out the positions of these Let me kick up the exposure just a little bit more. Okay, so VR2 and VR1. VR2 is for the 33 speed, VR1 45. So I already cleaned the VRs with contact cleaner. I got a screwdriver and started exercising those VRs, sprayed them out real good because I don't want any instability, intermittent behavior of these VRs either. So they're pretty much good to go. So when I flip this over, I'm going to make the adjustments with the pitch control, again, centered and get everything dialed in, okay? So the one thing I will say is if you do this adjustment, really watch your step or watch your steps because you have mains voltage coming in. Let me point that out. You have mains voltage coming in, the power cord right here. So if you're sticking your hand around here and you come into contact with that, you're going to be in for a rude awakening. It's better, and let me go ahead and zoom out a little bit. It would be much better, be much better to not drop the camera tripod, but it'd be much better to actually put the cover back in place. And there's access holes here for the VRs, but the only thing is that I don't know if there was ever any markings over these access holes to indicate which one is 33 and 45. But being that there's not, you can very easily just mark them on here. You know, check it out, look at the circuit board, and then mark the appropriate VRs, the speeds on the cover, you know, whatever. Just write it in there with a marker. It doesn't matter. That way you can put the cover back on and access the VRs with the cover on, so you don't run the risk of coming into contact with that mains voltage there. Okay. Especially if you're not experienced doing this. I'm going to do it with the cover off, and I'm going to assume the risk for that. You know, that's kind of my problem. But I'm experienced enough doing this where I'm going to be very careful. I'm going to look before I leap. But I'm going to flip this over and I'm going to do just that now that the VRs are clean and I'm ready to go. So let me go ahead and change camera position, all that stuff, and then I will be right back. And real quick, before I change camera views again and swing the camera over to the speed dots and the strobe and all that, so you can see the the speed coming into adjustment. I just want to show that I have the turntable up on blocks so I can reach underneath, and I have my little screwdriver to adjust those VRs. So that's what I'm going to do. I'm going to start with 33 RPM and then switch on over to 45 and get those dialed in. So anyways, let me go ahead and change views. And just for reference, you can see that I have the pitch adjustment centered. I added a little index line to the to the control there, painted on an index line, and I have the speed control set to 33 in the disengage position. So let me go ahead and go underneath and I'll readjust the camera and get you on the speed dots and the strobe. Okay, so for these adjustments here, we're going to be focusing on the bottom 2 rows of speed dots. Right now we're going to be focusing on the very bottom row, and like I said, I have the pitch adjustment centered and speed adjustment set to 33. I'm going to reach under here. I have a light, of course, so I could see the access hole. I'm not filling around blind with that mains voltage on that board. Okay, so this might take a little bit because a lot of times these adjustments are really touchy. Yeah, stupid flashlight. Trying to turn this flashlight off with one hand and okay. Excuse me. Bear with me here while I try to lock on to our speed. Getting there. It's just when I start to pull the screwdriver out, it it shifts a little bit. Almost there. Let me hit it again. Get the screwdriver back up in there. It is touchy. Let me see how that looks around back. Okay, yeah, and you can see we're locked on pretty good. I haven't got the new belt in yet. It's on its way. I just want to get this adjustment really close, and then when I get the new belt on, I'm going to want to tweak the speed again, but I'm going to be pretty much right in the ballpark, so when I slap the new belt in, it should be really close. So that's looking pretty good. Now let me switch over to 45, and we're going to monitor the speed dots above this set of speed dots that's locked on right now. So there we are, 45, and that, wow, that actually looks pretty good right there. Let me tweak it a little bit because it's kind of rocking back and forth a little bit, but that could be because I have that worn belt on there. Could be, but maybe not. Hard to say for certain, but let me tweak this just a little bit. Yeah, that VR is really touchy. And like I said, I clean these VRs really good. I sprayed them multiple times and exercised the VRs back and forth, and I think that might be looking okay. Let me see. Yeah, that's holding pretty good right there. Not too bad. So I'm right in the ballpark, okay? Looking really good. So when I get that new belt on board, yeah, I think we're good. So let me go ahead and switch camera views. Before I move on, I forgot to mention something. When I was adjusting for 45 RPM, when I was dialing it in, I didn't actually have a 45 on the platter. I do now. And as you can see, there's not really any difference to speak of. The appropriate speed dots are locked in still. There's no drifting or anything. And I didn't suspect there would be. I only bring this up because of consistency. When I'm dialing in speed and I want to do so accurately, I want to recreate real world conditions. So it just makes sense to me. I don't really think it makes much of a difference, especially with probably the majority of turntables. But I want the appropriate weight, you know, of course the platter mat obviously, and the appropriate piece of vinyl for the speed that's selected, especially when I'm dialing in my adjustments and I want them nice and accurate. Because after all, that's what's going to be taking place in the real world. But I just wanted to bring it up for consistency's sake. So there you go. I just wanted to mention that. Let me go ahead and move on now. Okay, and here we are with our Pioneer PL250. So I already performed the speed adjustments by adjusting the VRs that are accessible from the bottom with the pitch control right here centered, and everything went very well. I will zoom in real quick on the on the speed adjustment window here so we can view the speed dots. And then I will flip it over and at least show you the access holes on the bottom, okay, and which is which. But otherwise, let's go ahead and get to that. Okay, and as you can see, the bottom row of speed dots that's locked on is 33 at 60 hertz. And something I didn't explain, if you don't already know, is that these represent the rows, of course. You know, these 4 dots with 50, 60, 50, 60 represent the rows. So the top row would be 45 RPM at 50 hertz, and then 45 RPM at 60 hertz, and then 33 at 50 and 33 at 60. Obviously in the United States we're 60 hertz, so there you go. Now the next one we're going to look at is, of course, 45 at 60 hertz, so the third dot up, third row up, okay? So take note of that. And there we are, okay? 60 hertz, 45, there we are, third row, and we're locked in there, okay? So I wanted to explain that in case, you know, you weren't familiar with this and whatever. So they kind of staggered it, you know, 50, 60, 50, 60. They staggered it on the, this is the Pioneer PL250, whereas on the Technics turntable, they didn't stagger it. You can see 50 hertz, 45 and 33, and then 60 hertz, 45 and 33. So they didn't stagger it on this turntable. Okay, and as you can see, as far as the speed adjustment VRs, where they're located on the Pioneer PL250, right here, I ended up marking them, putting some stickers here for 45 and 33, as you can see. This is at, if you flip it over, this is toward the front of the turntable, okay? You can see the edge here. This is the front edge right here. So there you go. So make note of that if you're working on one of these. You know where the access holes are and which one is 45 and 33. There you go. Let's go ahead and move on. Okay, everyone, so we're getting into the home stretch. I'm going to do a basic setup on these turntables, but I'm only going to show one because the procedures are going to be the same across the board for what I'm going to do, and I'm just doing a basic setup. So let's go ahead and get to it. I'm obviously going to be performing the setup on the Pioneer PL250. So there you go. Let's get to it. So we want to start out with a level platter or level turntable. So as you can see, I'm going to check it on 2 planes. I have the torpedo level set up there. You can see the bubble right on the center. Now I want to check that we're level on the other plane here. All right, by rotating the platter. And I can't get a perfect side angle because, well, you know, the bench is in the way and all that jazz, but you'll get the point. As I zoom in here, I think you can see the bubble good enough. Yeah, I can. So we're leveled, so that's good. Okay, the next thing I want to do is stabilize the platter. We don't want it to rotate, so I just used a piece of Scotch tape. Normally, I like to use poster putty. I don't know where mine went. I had a piece in the shop that I kept in a little plastic baggie, but I can't find it for whatever reason. But I don't use anything that has you know, color in it. Just a plain white piece of poster putty. I'm sure you can probably use other stuff, but the reason I don't like to use anything with color because I don't want any dye in there to stain something, you know, the top of a deck. But the white poster putty, I've never had problems with it, and I like it because unlike tape, I don't have to peel it off after. I just stick the poster putty between the, you know, the deck and the platter. Obviously, just kind of press it lightly, and that's it. It holds the platter in place, and when I'm done, I just grab it and pull it off, and it's good. Tape, yeah, you can use it, but you don't want to use anything that has any real hardcore adhesive like duct tape or something real overly sticky. Scotch tape isn't too bad, but you do have to kind of peel it off after. I just put this piece on right here very lightly. I didn't really press it down. You can also use like that painter's tape because that has a tendency to pull off pretty easy without leaving residue. You have to be careful, especially if you're doing this on a nice wood deck. Yeah, you don't want to introduce any type of adhesives on there that's going to stain the wood or whatever. But on this plastic deck, I'm not too worried about it. But still, though, you want to be careful. But anyways, the platter is locked in place. It's not going to rotate around. Now the next thing I want to do is float my tone arm because I'm going to set the tracking force first, and I'll explain what that is in just a second. But let me go ahead and float the tone arm. Right now it's head shell heavy, so it's going to drop. And if I rotate the weight, and I'm rotating the weight, you can see my hand back here. I'm rotating the black band right here, and that's important because that's going to come into play in just a minute. But I'm rotating just the black band, okay, and I'm moving it clockwise. And let me see where I am. So when I move it clockwise, it's sending the weight rearward, okay, so that it lifts the head shell, it lifts the tone arm. And I'm going to kneel down and see right about where that tone arm is floating, because I want the bottom of that tone arm level in comparison to the top of the deck. And I think I just about a hair more, maybe like that. I think that might be on the money. Let's see. Yeah, I think that's pretty good right there. Okay, so now what I want to do is this silver portion or metal portion, brushed aluminum, whatever, portion of the weight moves independently of the black band. The black band on the back is what rotates the weight. So what we want to do is just rotate the dial that has the numerics on it. And now that I have the tone arm floating, I'm going to set the dial to 0. There's an index line right here. I don't know if you can see it, but there's an index line on this little section of tone arm back here. And I want to line up 0, the index line of 0, with the index line on that little rear portion of the tone arm. So the way I'm going to do that, I'm going to lock the tone arm back onto the rest. I'm going to hold this black band because I don't want the weight to move, I just want the dial to move. And I'm going to just move the metallic portion, the dial, over and match up those two index lines, and that tone arm is now set. You can see the tone arm just kind of floating around, I'm sure. And if I just give it a little tap there, you'll see it just floating, free floating up and down. All right, good. Now let me change the camera angle real quick. Okay, pardon the hand holding here, but I'm trying to keep the camera stable, and hopefully at this angle you could see that the tone arm is floating there level with the top of the deck. Okay, so we're zeroed out and that's just free floating there. Okay, now I'm going to use the weight to set my tracking force, and after I set it, I'll explain what tracking force is in brief. So we know that the tone arm is free floating, it's zeroed out, as you can see there. So I'm going to rotate the weight, and I'm going to rotate it counterclockwise. The counterclockwise rotation is going to bring it forward. Okay, and that's what we want, because we want to add some weight to the head shell now, to the tone arm. All right, to set our downward force and again our tracking force. So I'm going to do that, and I'm going to rotate the black ring. Okay, not the metal part by itself, because that's just the dial. Okay, we're going to rotate the black ring here counterclockwise. And the tracking force for this cartridge is between 1.5 to 2.5 grams. Okay, so I'm gonna just set it at 2 grams. Okay, so you'll see I'm rotating it. There's 0.5 gram, there's 1 gram, there's 1.5, and I'm just gonna set it at 2 grams to start with and see how we do there. Okay. And then I'm going to verify that using an actual digital scale. But let's see if that got us, in the ballpark. Some, tone arm weights, tone arm setups are pretty darn spot on. Some not so much, but we'll go ahead and check it out. So anyways, you saw me rotate that counterclockwise to bring the weight forward and set our 2 grams at the index line. And that's what I did. So let's go ahead and confirm that. Okay, so we're going to start by making sure that the scale is in calibration, that it jives with this 5 gram weight. Let me just carefully set it on the scale. Okay, and you can see that it's calibrated 5 grams. So now that we know our scale is accurate, let me go ahead and I'm going to set the stylus right on that little black dot there, okay, that target. So and you see that it's reading 2 grams or 2.01, close enough. It moved a little bit. Initially, when I first set the tone arm down, the stylus down, it was 2 grams on the money, but good enough. 2.01. Can't argue with that. That's looking good. All right. So what that measurement was all about, the tracking force, is the downward pressure that's exerted into the record groove. All right, so when you set that weight, that's what you're doing, and you want to make sure that you're in the ballpark with that downward pressure or force based on the manufacturer's recommendation. Okay, so I'm going to talk about a few other things here as far as some other calibrations or measurements that we want to take to assure that our cartridge is positioned optimally as far as what we're able to do realistically based on this turntable / tone arm design. Okay, so there's a few other factors that we want to check out, and I'm going to get into that. So for this basic setup, I'm going to be checking what's referred to as our zenith or yaw angle. Okay, and I'm going to explain what that is along with a few other settings, a few other angles that are often measured and set accordingly for, again, optimal positioning of the cartridge / the stylus. Okay, so let me just talk about the other ones first. So I'm going to use my hand to demonstrate the angles that are considered when setting up a tone arm, cartridge, stylus, whatever. So first of all, I'll talk about the the rake angle or vertical tracking angle, or I will also use the term pitch angle. So picture my hand, you're looking at the side of the cartridge, okay? You're looking at it side on. So the rake angle, or again, pitch angle, is this right here, okay? That's the pitch angle. I use the term pitch angle primarily. That's what I use a lot. So that's kind of what I'm used to. But again, the stylus rake angle or the vertical tracking angle, either or, whatever. So the way that you would adjust this pitch angle here, or rake angle, is a couple ways. If the tone arm has that capability, here at the base, some tone arms have an adjustment. You could raise and you can lower the that pivot point there, and that will make some adjustment to that pitch angle that I'm talking about. However, if that's needed for whatever reason and the tone arm base doesn't have that capability, then sometimes some folks will use shims at the head shell here to try to establish a little bit more of a pitch or rake angle, okay? Ideally, what we're trying to do, and let me go ahead and change camera positions. Okay, so we're looking at my blackboard. There I am in the reflection. Hello, everyone. So anyways, and I even got my nerd glasses on. So this is a blackboard next to my bench because, I don't have a computer monitor for pulling up PDFs and schematics and all that. I still print them, and I'll stick them here on the blackboard, or if I need to take notes or something on whatever. That's why I have a blackboard next to my bench. So that being said, you can see here, and you might gather that I am not an artiste when it comes to drawing. However, you get the point. So this is Mr. Happy cartridge, okay? And the tone arm. This can be our record or whatever. Doesn't matter. Here's our cantilever and our needle. Okay, so when it comes to the stylus rake angle, pitch angle, and all that, the objective is we want our stylus, our needle, nice and straight, okay? Right on pretty much 90 degrees, perpendicular to the record surface or whatever. Now, when that adjustment is made, some people will kind of cant it, about 92 degrees or whatever. You can look that up. There's information on adjusting rake angle if you're going to do that. If your, tone arm base has that capability, or if you're going to shim that. But in all honesty, if the stylus, cantilever, all that is properly formed during manufacturing, there isn't any defect, or it's not off, it's not cattywampus, or whatever the case. Once that stylus and all that is attached to your cartridge, and the cartridge is mounted properly, either factory mounted or whatever the case, doesn't matter, but everything should be in the ballpark. You shouldn't see anything like this. You don't want, this just represents the stylus, the needle. So you don't want the needle, canted over at a funky angle. You pretty much want it straight on, straight on vertical, our 90 degrees here, or pretty close there too, 90 degrees, 92 degrees. So this is our stylus rake angle. This is what I'm referring to, that angle, okay? So there you go. All right, the next angle to consider is something called roll angle or azimuth. Now, if you notice our head shell here, let's go ahead and replace it with my hand, okay? We're looking at the top, the flat area of the head shell. Now let's say my hand is that, okay? So azimuth roll angle is this here, all right? And we want to make sure that we don't have any roll to this head shell cartridge, or whatever the case, any funky tweak of the cantilever. So the reason that is because as the stylus rests in the groove, okay, this V of my fingers here is the record groove, all right? And my two fingers in that groove, all right, should be nice and straight. Shouldn't be rolling to one side or the other and favoring one channel of that record groove over the other. It should be nice and balanced, sitting right there in the middle and not leaning over to one side or the other. Okay, I'm not going to get into all the reasons as to why. I think some of you know that. Some of you can kind of guess. If not, do your research. I'm just talking about the angles and how they're applicable to setting up a turntable and optimizing the cartridge slash stylus position in the record groove, and again, optimizing your sound experience. So there you go. Now, our next angle for consideration, and again, what I'm going to use the protractor for, is something called our zenith, our horizontal rotation, or zenith, or what I refer to as the yaw angle. And again, my hand down here, this is the top of the, let me actually, I think there's a better position. Okay, so my hand is the top of the head shell once again, okay? This is the angle I'm talking about right here, the yaw, okay? Or our horizontal rotation, zenith, whatever, different names, but yaw angle. Okay, so we don't want this head shell, kicking over too far one way or the other. We want it nice and square, and that's what we're going to achieve with this protractor to get it as close as possible, and I'll go ahead and explain that. Now, rewinding a little bit to the roll angle that I was just talking about before this, as far as adjusting that, I didn't touch on that. Again, that's an adjustment that should be in the ballpark just from the factory, provided that the tone arm, everything is good with the tone arm and the way the head shell mounts to the tone arm, that it's not tilted, hence roll angle. So everything should be pretty on the money. If not, if something was tweaked, and again, the cantilever, as long as that's not tweaked, everything's good and formed properly, by the manufacturer, then everything should be pretty much right on in the ballpark. But if not, that would require some little shims to be installed, under that head shell to, maybe give the right amount of roll to compensate. Okay, so there's that. Now, going back to the current adjustment that I'm going to do here is, like I said, the the yaw angle, and that could be brought into proper alignment via these screws here. So if I loosen these up a little bit, I can maneuver the cartridge just so, in order to get that, to get the proper to get the proper yaw angle. If it's not straight on, and there's a little bit of a discrepancy in that yaw angle, then again, I can use these screws, loosen them up, and move the cartridge accordingly. And I'm going to use this protractor to do that. So let me show you what we're looking for. So for this zenith or yaw angle adjustment, horizontal rotation, whatever, there's so many different descriptions for it. Anyways, for that, you just want to get this protractor into position so that when you bring the tone arm over, you set the stylus down on a null point, N-U-L-L, that's located here on the protractor. And let me go ahead and zoom into that null point. Okay, so this is our first null point here, this little dot. Okay, you see the little dot there? And there's another one over here. And we're going to be utilizing both of them. We're going to be checking that yaw angle, and I'm going to show you how we do that. But we're going to be setting the stylus down on these null points, okay, throughout this process. So let me go ahead and change camera angles. Okay, so here we are at kind of a overhead side view. I would like to be directly overhead, looking straight down on the front of the head shell and cartridge, but I can't do that with my setup. So you might be able to get an idea. So what we want to look at is the front of the cartridge versus, you see these lines obviously running parallel to the front of the cartridge. So the line closest to the front of the cartridge there, we want to compare and see whether or not the front of the cartridge here is right on the money parallel, running parallel with the with the line directly in front of it, okay, the closest line that's in front of it. And from what I can see, it's hard to see at your angle, probably nearly impossible at that angle, but I'm looking down directly overhead and I can see that there's a little bit, and I'm talking just a fraction more space on this side of the cartridge over here than there is on the other side. So if you were standing where I'm standing and looking at the front of this cartridge face, there's a little tiny bit, a hair more space on the right side of it than there is on the left side of it over here, just a little bit. So I need to tweak the cartridge a little bit this way, okay, so this way, like that, all right? And I'm going to loosen the screws just enough to do that, not too much, just I'm going to back them off just a hair because I want a little bit of tension, a little bit of friction or tension, whatever, between the cartridge and the head shell. I don't want it all loosey-goosey because I just want to be able to give it a little bit of an oomph. That's it. And then tighten it back down. All right? And then I'm going to do the same thing when I adjust it in this position first. When I get it lined up over here, then I'm going to repeat the process. I'm going to move the tone arm over to this other null point. I'm going to look for the same thing. And if I need to give it a little tweak, just a tiny bit over here, I'll do that. And then I'll have to kind of go back and forth. And there might be a little bit of a compromise, but it's finding that compromise between the two null points so that the face of this cartridge is running parallel with the lines in front of them when positioned over these two null points, when the stylus is sitting exactly on these null points, okay? So again, there might be a little bit of a compromise. You might have to use a little bit of English or just kind of just tweak it just so that it's as straight as it could be between these 2 points in reference to these parallel lines in the front of the cartridge once again. So that's what I'm going to be doing, and I hope that was a pretty clear explanation. There's really no point in me continuing video footage, doing the little tweaks, because I already explained what I'm going to do with just backing these screws off a little bit, tweaking the cartridge a little bit until I get that alignment right on the money, and going back and forth and checking it. So if I could get the camera in at a better angle where you can see exactly what I was seeing and all the little detail, then I would probably keep rolling the video footage. But because I can't do that, there's no point in me sitting here tweaking what you guys can't see. but I think I've explained it well enough to where you know where I'm going with this adjustment. So there you go. So I'm just gonna leave this for now. Let me go ahead and change the camera view real quick before closing out. All right, so everything, you know, other than these last adjustments that I'm going to do over here between these turntables that I just explained, other than that, everything is pretty much done. On this Technics over here, I'm waiting for the belt, which I have on order, and I'm also waiting for the stylus for this one as well. That's on order too. But I know everything is good. I know the cartridge is good. I know that there's output, you know, making its way out of the RCA cables over there. Everything is intact. So, and of course, mechanically, everything's functioning good. I already demonstrated that. The speed adjustments, everything. So we're looking good there. And as far as this Pioneer over here, the cartridge and stylus, or excuse me, the stylus that is on board is a new stylus. So this has a new stylus on it. This one actually, after I do the adjustments, is ready to go, because obviously this is a direct drive, so I didn't order a belt for it, obviously. So anyways, so this one's all ready to go. Cosmetically, I've cleaned them up pretty good. So on this one, when the belt arrives and the stylus, this thing's going to be ready to go too. So I'm just going to leave it at that, guys, because this video got really long. So as I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This has been a Spinning Head production.